A pair consists of two values that are joined together, bundled together in such a way that you can treat them as a unit, as a whole, even though there are two parts. Now there's lots of different ways to represent a pair of things, but we're going to use a built-in data type first called the list. So I can write the line of code pair equals open bracket 1, 2 close bracket. And what we have here is what's called a list literal, which creates a new list that contains 1 and 2 as two values. And since we have two values in the list, we'll call it a pair. And when I display this pair, I see its contents, written just like the literal. So a list literal is a comma-separated expression in brackets. Once I have a list, which is the value of a list literal, I can access the elements within the list through what's called unpacking that list into different values. So by saying x comma y equals pair, I'll bind x to the 0th element and y to the first element. After which, if I look at what x is bound to, I'll see 1, and what y is bound to, I'll see 2. That's because that's the contents of the list that I've created. So we now have a way to bundle together values and split them apart again. This is called unpacking a list. Another way to access the elements of a list is through the element selection operator, which again uses square brackets. So these square brackets are different from this one, although they're certainly related. But this is just square brackets without anything before it, whereas this has some expression before it. So when you have square brackets after an expression, that involves selecting an element from the value which is to the left of the brackets. So pair is a list value, and its 0th element is 1. Its first element is 2. So element selection using the selection operator is another way to access the elements in a list. There's also a function that does the same thing. As we've seen many times over in Python, each operator has some function, most of which are within the module called operator. So the element selection operator is called getItem, all one word. It's okay to say it fast because it's all one word. GetItem pair 0 gives me the 0th element of the pair list, and that's 1. GetItem pair 1 will give me the value 2. And this is an element selection function, or the getItem function. Okay, we now have a basic introduction to what lists are, and so far we've used them to create pairs. And why is that useful? Well, a rational number is a pair of integers, the numerator and the denominator. So here's a definition of the constructor of the abstract data type for rational numbers. It's a function that takes in the numerator and denominator, and we need some way of representing that pair of things. We'll use a list. So we construct a rational number that represents n over d just by returning the list of n comma d. So this constructs a list, and the list we're using as a rational number. Now lists can contain anything. They don't necessarily just contain integers. But we're using it to represent a rational number in which both n and d should be integers. Now, how do we get the numerator out, assuming that x is what was created by the rational constructor? Well, we just access the 0th element. And the denominator is element at index 1. So we're going to select an item from a list here in order to implement what we want, which is selecting the denominator of a rational number. So let me show you the first example of why data abstraction can be useful. Recall that we implemented multiplication among rational numbers. And here's an example, 3/2 times 5/3. And what do you get? Well, you multiply the numerators together to get 15, you multiply the denominators together to get 6. And the answer is not 15/6, but 5/2. And why is that? Well, we had 15/6, but those were not relatively prime integers. We can reduce the fraction to lowest terms by multiplying both the numerator and the denominator by 1/3, and that gives us an equivalent fraction 5/2 that's simpler. Now, the reason we do this is in order to keep the integers small so that they're easier to look at and understand. What about 2/5 plus 1/10? Well, we can apply the same procedure we had before for adding together rational numbers. And we'll get 1/2. Now, why is it 1/2? It's because through the cross multiplying and addition, we got 25 over 50. And so there's the 20, there's the 5. We add those together to get 25. 50 is 5 times 10. But then we can reduce that to lowest terms by multiplying both the numerator and denominator by 1 over 25, leaving us with 1/2. So how would we change our implementation to do that? Well, here's the idea. Addition and multiplication actually were correct in the first place. What was wrong was our definition of rational. A rational number should be something that's always represented in lowest terms, or with two relatively prime integers. So one thing I can do is import a function that computes the greatest common divisor. In a previous lecture, I showed you how to write a function that does this, but it also happens to be built into Python. And then what I'm going to do is redefine the rational constructor to take any numerator and any denominator, and then constructs a rational number that represents n over d, but does it in a way such that the numerator and denominator that are accessed later are always relatively prime, which you can achieve by computing the greatest common divisor of both the numerator and the denominator. That's 3 in this case, or 25 in this case, and then returning a pair that contains the numerator and denominator each divided by the greatest common divisor so that they're guaranteed to be relatively prime. And we use integer division here because we know that g evenly divides both n and d. That's a property of a greatest common divisor, is it's a divisor. It evenly divides those numbers. Okay, so we computed the greatest common divisor. We changed the constructor. We don't have to make any changes to add rational or mul rational or print or anything like that because we've been using data abstraction, which means that everything was defined in terms of this constructor. So changing this constructor changes the behavior of all the other functions as well. And that's a good thing.